Hi everyone, here's the next video in our set. As I promised, we're going to talk about equations and tables. And so notice I already have a relation set up and graph for you. So the equation 2x minus 3y equals negative 9 is a relation. We'll learn that later on. It's a special type of relation with its own name. But for the moment, we're just going to be interested in graphing it. Now in chapter 3.1, we'll learn a whole bunch of graphs that have certain patterns to them. But right now, we're just going to brute force this. And by that, I mean we're just going to create a table of values and just plot the points. So this one's already set out and already graphed because I want you to kind of see, working backwards, how did I get this graph? So what I'm going to do is I'm going to set a table. So let me make this smaller. And I'm going to create an X column and a Y column. And then I'm going to have a column which is the ordered pair X, Y. Sorry. And so notice that the x-coordinates of the points that I graphed were negative 6, negative 3, 0, and 3. And I'm going to get rid of this grid here for a minute. So I think, at least for me, it makes it easier to see. So now we need to figure out the corresponding y-coordinates. So usually what you do here in these type of problems is you pick your x-coordinates. What you pick is completely up to you and depends on the problem. In this case, I just had nice points because I graphed it ahead of time, so I knew which points to pick. But in general, you could pick anything you like. As long as you get a certain amount of points, you should be able to graph it. So in this case, let's show how we get the y part. So we're going to take this y value. So let me grab a different color pen here. We're going to take this negative 6 and plug it in for this x here. So I'll do that down there. So I want to have 2 times negative 6 minus 3y equals negative 9. And notice that this negative 6 that I replaced x with, I put in parentheses. There is a reason. I learned as a student of algebra myself that when I put parentheses in like that, it helped me avoid sign errors. So I recommend that you put those parentheses in whenever you replace a variable. And we'll see this example again. See this again in the next example. So let's multiply the 2 by the negative 6 and get a negative 12 minus 3y equals a negative 9. And moving the 12 to the other side, I get negative 3y. Actually, let me add a step in. So adding 12 to both sides like this, they cancel off, and I get a negative 3y equals a positive 3. And dividing both sides by negative 3, I get that y equals negative 1. And that's what goes into the spot here. Oh, I forgot my negative sign. You'll find that even though I am well practiced in math, I still make sign errors like that. And then we do the same with the other coordinates, but I already figured everything out ahead of time. So we get a 1, a 3, and a 5 here. So that corresponds to the negative 3, 1, the 0, 3, and the 3, 5. And once you have these points, then you can take them. Let me grab a different color. You can take these points and graph them. And so once you graph them, you're going to get something that looks like this. So let me get rid of all this red ink and blue ink. I'm going to zoom into this part here. And after you graph those points, you're going to get something that looks like this. And once you plot your points and you have enough of them, and again, enough is going to depend on your situation, then you just play connect the dots. And you get a graph of a line. Wow, that was easier than using the graph paper, actually. So notice what I did was I had my equation. I made a table of values to get a whole bunch of points from this table of values and graph them, and then you play connect the dots. And that's how you come up with the graph. Now, not all graphs are going to be as simple as this. Lines take very few points. In fact, 2 points will determine a line, but I do recommend 3 for a line. Down here, though, for this example, it's going to take a couple points here. So let me graph this on graph paper. Let me turn it to view. So I'm going to need a bit of room here because, oops, practice calculations that I don't need. So let's see. So I'm not going to need very much in the x direction, but I'm going to need a lot of y in this problem. Well, let's see if that works. I think this will do me just fine. So here's 1 and here's 1. So the first thing I want to do is again create a table of values. Go away. Don't need that one. So here again I'm going to have x, y, and x comma y. And so I'm going to pick -2, -1, 0, 1, and 2 to replace x in and figure out what the corresponding y value is. Now I'm only going to do this for one of these values, but I've already figured this out ahead of time, so I do know what the other y values are going to be. And so again, we're going to take this -2. I'm going to take this -2 and plug it in for this x cubed, and that's going to give us our equation down here. So again, I want to take the -2 and replace it with x and put parentheses there, and then the exponent goes on the outside, and this is very important. For odd exponents, you'll get the same answer, but if you don't put the parentheses in, and you have an even exponent, this does make a difference. So this parentheses is definitely required. Plus y equals 1. And then we're just going to simplify this. So we're going to get -2 cubed is a -8, plus y equals 1, and then y equals 9, and we get the point 9 here. So this will be a -2, 9, and then plug in the other values similarly will give you a 2, a 1, a 0, and my 1 didn't go in there all that well. A 1, a 0, and a -7. And so that corresponds to the points -1, 2, 0, 1, 1, 0, and 2, -7. So let's get rid of all this blue here and let's plot some points. So we want to go to -2, 9. So here's -2 and we need to go up 9. So let me see. So 1, 2, 3, 4, 5, 6, 7, 8. Yay, my graph works. Or I had enough room. -1 goes only up 2. So we're going to go 1, 2. So here's my point. So this it's always a good practice to label points if you have the room. So -1, 2. My next point is 0, 1, which is right here. My next point is 1, 0. And these are all kind of cramped. But here's 0, 1. This point here is 1, 0. And then lastly we have 2, -7. So we'll go 1, 2, 3, 4, 5, 6, 7. So here is 2. And because I know properties of this function, I know this is curved. For me, it's easiest to draw it like this. And like this. Oops, that was wrong. Let's try it again. I see. It was easy. And of course I hit the start button doing it this way. There we go. Oh, that's ugly. One more time. If it doesn't work, we're done. There, that's better. And there's our graph. And in fact, I graphed this on a calculator already, so let's see the calculator and notice that it looks very similar to a calculator. If you don't know how to do this on your graphing calculator, we will do this at a later point. So that's how you graph these types of functions using tables. So notice that tables for equations cannot represent every point on the graph, but we can use tables to represent some of the points and use those to figure out what the shape of the graph is. And that's it for this video. Sorry, this one was a little longer than the others. Up next, we are going to look at the midpoint formula.